Okay, hi, this is lesson 3, 4, chapter 3, lesson 4. Find slope and rate of change. Find slope and rate of change. Okay, here's our key concept. Our key concept is about finding the slope of a line. Okay, the slope, and we're going to refer to it a lot as m. You'll see the variable m used a lot in equations. So just keep that in mind when we talk about m or slope. Those are interchangeable. Okay, the slope m of the non-vertical line passing through the 2 points, x sub 1, y sub 1, and x sub 2, y sub 2, is the ratio, and again, ratio is like a division problem or a comparison, of the rise or the change in y to the run or the change in x. And I know this definition sounds confusing, but as we go through this lesson, it will get less confusing. So just make sure you get this into your notes so that you have this to refer back to. The slope is a rate of change. Okay, the steeper the line, the more quickly things are changing. The less steep the line, the slower things are changing. Okay. Okay, here's some things you need to know. Slope, these are all interchangeable things. Slope is the same thing as m, is the same thing as rise over run, which goes back up here to this ratio, okay? A ratio of rise to the run, rise over run. In other words, the change in y, how the y changes over how the x changes. And here's how we show where the y changes. We take the coordinate of the y sub 2 and the coordinate y sub 1, and we subtract those, and we subtract the x's as well. And we'll practice this, okay? But I do want to give you some other terms for slope, because there's lots of terms. We are going to call it a lot of things, and you need to understand all of these things are going to mean slope. So on your notes, list under known as slope, m. These are all things. I might say m, I might say slope, I might say any one of these terms. A word problem might say any one of these terms, and they'll all be the same. Rise over run. Change in y over change in x. Rate of change. And change in dependent over change in independent. And this is the least common. It's why it's last. But again, dependent is always your y, and independent is always your x. So it's very similar to this one. Change in dependent over change in independent, or change in y over change in x. You're going to hear this one, this one, this one. Well, the first 5. You'll hear the first 5 quite a lot. These are the 5 most common that you will hear. And all 5 of them are going to represent the slope. Okay? Think of a hill. Think of the slope of a hill or a ramp, that type of thing. That's what we mean by slope, the way something slopes. Okay? So, here's our first example. Find the slope. Notice from left to right, this one is going uphill. It looks like it's going uphill. And we're going to find the slope, or how steep it is, or the rate of change. Okay, so one way you can do this is if you have a graph, you can always just count the change in y from this point to this point. So from here to here, we go up 4, and up on the y-axis is positive, and we go then to the right 6, and to the right on the x-axis is positive. So it's a positive 4 over a positive 6. That's one way you can do it if you have a graph, just by counting. So we're going to go ahead and write this, positive 4 over positive 6, which equals 2 over 3, because 4, 6 does reduce. So technically, if we go up 2 and over 3, you'll notice that line crosses right through that point. But now we're going to use these coordinates and show you how they work with that little formula we saw a little bit ago. So let x sub 1, y sub 1 be negative 4, 2. So this one is going to be 0.1. Okay? So x sub 1, y sub 1. And x sub 2, y sub 2 is going to be 2, 6. So this one is 0.2. So we have 0.1 and we have 0.2. We know that it's going uphill, so it should be a positive slope, which it is. And we're going to plug these in. Okay, notice we've labeled the x's are in blue, the y's are in red, and we're going to plug these in for the formula. Here's the formula. Slope, or m, equals the coordinate point, the y sub 2, which is this one, and the y sub 1, which is this one. So here's my y sub 2, my y coordinate from point 2, and my y coordinate from point 1. I'm going to substitute those in. Same thing with my x's. My x coordinate from point 2 minus my x coordinate from point 1. That's all these little sub numbers mean. Okay, they're not exponents, they're little sub numbers. Okay, and that's all they mean, is the representation of which y we are talking about and which x we are talking about. So now let's make the substitutions. So we're going to substitute. Notice my 6 went in for my y sub 2, and my 2 goes in for my y sub 1. And you guys, it doesn't matter which point you label point 1 and point 2, as long as you label it and you use the same y and x from the same point as your first coordinate. So 6 minus 2, y sub 2 minus y sub 1, over 2 minus my x sub 1, which is a negative 4. So look here, we have a minus a negative 4. This is what confuses a lot of kids. Make sure it is minus. This is a set minus in here, no matter what your x sub 1 is. Even if your x sub 1 is negative, that minus has to be there. So now we're going to simplify. 6 minus 2 is 4. This technically becomes a 2 plus 4, because it's 2 negatives make a positive. So we end up with 4 over 6, which is 2 over 3, which is exactly what we got when we counted. Notice our y goes up 4, so our change in y is 4. Our change in x is 6. So there's our first example. Okay? Now this is going to be a slope that we are going from left to right. We're going downhill. So our slope is going to be negative. Okay? Now, again, we have a picture, so we can always count from this point to this point. And we go down 1, 2, 3, 4, 5, 6. So my change in y is negative 6, because down on the y-axis is negative. And my change in x is 1, 2, 3, because from this point to this point, I have to go over to the right 3, and that's always a positive. So my slope looks like this. And negative 6 divided by 3 is negative 2. So and then we can say negative 2 over 1, but we had understood that it's over 1. So my slope is a negative 2. It's going downhill. So let's go ahead and substitute those points in just to practice again. We've labeled this one point 1 and this one point 2. So we're going to substitute negative 1 minus 5. There's our formula. Slope equals. Okay, we're going to substitute negative 1 minus 5 for my y's, and 6 minus 3 for my x's, and then we're just going to simply solve. Negative 1 minus 5 is negative 6, and 6 minus 3 is 3, and we end up with exactly what we showed here. Now I know you guys think that this is much easier, and it is, and if you have a graph, I am all for you just being able to count your slope, count your change in y, and count your change in x, and finding your slope. It's going to be when you don't have a graph. Okay? All right, let's look at this. We talked about these lines yesterday, or day before, I'm not really sure which, but this is a slope that's flat. It's not going uphill, it's not going downhill, it's going straight across. It's flat. There is no slope. So the slope of a line that's horizontal is 0, and let's show it mathematically. So we have our point 1 right here, and we have our point 2, and let's write our formula and substitute in. So we end up with 4 minus 4 over 4 minus a negative 2. Well, when we get 4 minus 4, what do we get in the numerator? We get a 0. And anytime you have a numerator of 0, you have just a 0. So our slope is 0. In other words, it's not uphill, it's not downhill, it's nice and flat. There is no slope. All right, example 4, a vertical line. This is the key. You guys, I hope you're writing this. This is also on your notes. These little things right here are on your notes. A vertical line, the slope is undefined. The way I say it is it's so steep. It's just a drop off. There's no definition. The rate of change is so steep that there's no way to even define it. It's not a flat line. It's not zero. It's just undefined. Now let's show this. Okay, here's my point 1. Here's my point 2. Okay, so I'm going to do 1 minus 5, just showing you ahead. There's our formula. It's going to be 1, the y sub 2 minus y sub 1, so 1 minus 5 over 3 minus 3. You see that right there? And when we simplify, we end up with negative 4 over 0. We cannot have a 0 in the denominator. Cannot do that. It's an undefined when you have division by 0. There's no answer for it, basically. Okay? So, undefined slope would be a vertical line. All right. Not the last thing, but almost. We're going to look at some table. The table shows the cost of using a computer at an internet cafe for a given amount of time. Find the rate of change in cost with respect to time. So I'm going to just have you label, this is my x, because this is what I can control. I can control the time I spend in the internet cafe. So this is my independent variable. And call this y, because this is my dependent. My cost depends on how much time I spend. Okay, so we're going to look at our rate of change. So our rate of change is going to be the change in cost, which is our change in y, over our change in time, which is our change in x. So our slope, or our rate of change, is always going to be y over x. Always. Always. Dependent over independent. So what they have here, let's go back to the table and look. And I just want to show you something. Right here, sorry, too far back. Right here, let's look at how this changes. So my x increases by 2 each time. What happens to my y? My y increases by what? By 7 each time. Okay? So my change in y is 7, and my change in x is 2. So there is my rate of change. So it's $7 for every 2 hours. Okay? So let's look at that. Let's see what they show. So 14 minus 7, they do the subtraction. They take 2 of the points and they do the subtraction. I just like seeing the rate of change. And 14 minus 7 is 7. 4 minus 2 is 2. They still get 7 over 2, or $3.50 per hour. Okay? $7 for 2 hours, or $3.50 per hour. That's how much it costs to use the internet. All right, and the last little bit, a student commutes from home to school by walking and by riding a bus. Describe the student's commute. This is a little bit interesting. Okay, here is how far they're traveling. Okay, how far they go up is how far they travel, and this is the time it takes. So, like, let's just say if this is 100 yards. Okay, so this would be 200 yards and 300 yards. Okay, think of it that way. I don't know exactly what it is, but let's just give it a picture. So they travel 100 yards in 4 minutes. Okay, so that might be where they're walking. Does that make sense? They take 4 minutes to go 100 yards. And then from 4, 5, and then to about 6.5 minutes, what are they doing? I'm thinking they're standing still. They're not moving. Okay, they're just standing there for a few minutes, probably talking to their friend, telling their friend goodbye, or they're waiting on the bus. Maybe they're walking right here to the bus stop, waiting on the bus for a couple of minutes, and then they get on the bus, and look at how all of a sudden on the bus they go quite far in a much faster time than they went here. That's just interpreting a graph and just showing the as the rate of change. Walking, not moving, and then bus. All right. Sorry this video is long. There's your words. Hopefully that's on your paper. And you can stop the video and do your guided practice.